Hello, my name is Annie Wang. I go to Foothill High School, and this is my second milestone video, which shows the modifications to my intensive project, the Smart Mirror. So basically, I am adding a ultrasonic sensor to detect if obstacles are standing in front of the mirror. And then this is an LED strip, which each LED is individual adjustable. So each LED can turn like a variety of colors based on your code. It could run through just different patterns like a rainbow or like some carnival like patterns. So first I'm going to explain the ultrasonic sensor. Basically there's a transmitter and there's a receiver. The transmitter will send out an ultrasonic wave that if there's an obstacle standing in front of it, the wave is going to hit off the obstacle and be captured by the receiver. So basically, it's going to calculate the time it took to go out, the wave to go out and then go back, and then knowing the speed of sound, which is 343 meters per second, which then by knowing the time and the speed of sound, you can calculate the distance from your sensor and the obstacle. And I'm using this so it could detect myself when I'm standing in front of the mirror. When I'm standing in front of the mirror, it will turn the mirror on, and then when I'm away from the mirror, it's gonna count a few seconds of inactivity, and then it's gonna turn off. So I'm gonna run it right now, and then it shows the calculated distance in inches. This is just for debugging purposes. And then it shows how each calculated distance in each repeating every 2 seconds. And then if I put my hand in front of it, it's gonna hit this threshold. It means I'm like standing in front of the mirror. And then after some time, the mirror's gonna turn on. And then it turns it on. And then, yeah, that's when I'm standing in front of it. I can look at it. As long as I'm standing in front of it, it will stay on. But then I'm gonna show you, yeah, when I put my hand away from it, it's gonna count. It's gonna count to 15 seconds, and then it's gonna turn off the magic mirror. 15, and then it stops. And then that's just for the ultrasonic sensor. I'm also implementing the LED strip that will go around the monitor just for decoration. And then I'll just show you how it looks like. So if I just go to it and then run. Yeah, and then it's gonna turn on and play a variety of different patterns and colors, just like that. This is not how the final is gonna look like. This is me just trying out the LED strip and seeing what colors it can display. Yeah, so basically, a few challenges I faced during this whole project was actually wiring the ultrasonic sensor, because the Raspberry Pi GPIO pins, which stand for general purpose input output, one of the pins, it's just that, so the ultrasonic sensor runs on 5 volts, but then the GPIO pin runs on 3.3, and then by adding too much voltage like that, it can damage the pin. So I use a circuit board to wire a voltage divider circuit, which basically lowers the voltage to 3.3 so the GPIO can handle it. So I use 2 resistors here, one 1K ohm resistor and one 2K ohm resistor. And then another challenge I faced was just wiring the LED strip, figuring it out, because it has this signal input in the middle, and then I had to wire it also to a Raspberry Pi along with the circuit board. It was a little confusing for me to figure out where the wiring was supposed to go. but fortunately this Raspberry Pi has two 5 voltage pins, so it worked out. And then for my next steps before my final milestone is to code the LED strip. Basically what I'm trying to code it for is that it's gonna take information from the magic mirror about the weather, whether it's cloudy, whether it's rainy or sunny, and display a color. Like if it's cloudy, I might display like a light blue color, or if it's sunny, I might want to display like a yellow color. And that's for the LED strip. And the final things is to assemble it, assemble this to the frame and with the LED strips around the monitor, and then installing the ultrasonic sensor so it could detect me.